Hello everyone. In today's session we are going to discuss about one of the most important machine learning unsupervised algorithm, that is DBSCAN algorithm. It is a density based spatial clustering of application with noise. It is a popular unsupervised machine learning algorithm and specifically used for the clustering task. It groups the data points together that are closely packed and mark the points that lie alone in low density regions as outlier or noise. And generally, in order to work, this DBSCAN algorithm has two important parameters, that is the minimum points, also known as the minimum sample, and next one is the EPS value. Whereas the minimum points, generally it is specifies that the minimum number of the data points required for a cluster to form a dense regions. A cluster will be formed on the basis of these minimum points. And the next parameter is the EPS, and generally it is a distance measure that is used to specify the neighborhood of any data points. If the distance between 2 points is less than EPS, then these two data points are neighbor, else they are not neighbor. And these are the two parameters that we have to specify in this DBSCAN algorithms. And hence, after DBSCAN algorithms works based on these two parameters, there are three types of the points that need to be considered in this algorithm. The first is the core points, and the core point is a data point which is used which is specified as a core point if there are at least minimum points number of data points within the EPS radius. And border points are the data points, and they are said to be border data points that are in the neighborhood of a core point but has lesser number of the minimum points within the ERP radius. And generally, noise outlier points are the data points that are said to be a noise or the outliers if it is neither a core point nor is in the neighborhood of a core point. How the algorithm works? Firstly, at the beginning we have to specify the minimum points, or that is the minimum samples, and EPS are defined. And in second step, randomly we pick a starting point from the data sets. Its neighborhood is defined within the EPS distance, and if there are at least minimum number of points within this neighborhood, then this data point is classified as a core point. In next step, the algorithm continues this for all points. It finds the neighboring data points within the EPS and identifies core points. For each core point, if that point is not assigned to a cluster, the algorithm creates a new cluster. In next step, the algorithm then finds all the neighboring points using the distance matrix, and if there are at least minimum points within the EPS radius for the considered data point, then all these points are part of the same cluster, else they are not the part of the same cluster. And in next step, the algorithm travels to the unvisited points. If they are not part of any cluster, then mark them as outlier or noise. And in last step, the algorithm terminates when all the data points are visited. Next slide. It is DBSCAN is a density-based spatial clustering application with noise. It is a popular unsupervised machine learning algorithms used for the clustering task. It groups together the points that are closely packed and mark the point that lie alone in low density region as outlier or noise. And generally, DBSCAN, this is the name of the algorithms, and its full form is density based spatial clustering of application with noise. And unsupervised machine learning algorithms. It is among unsupervised machine learning algorithms. It means it doesn't need the label data for the working. It finds patterns, that is cluster on its own in the given data sets. And next, it is used for the clustering task. It means clustering means it will group similar data points together. For example, grouping similar customers or objects, video frame, etc. And next, here is it groups together the points that are closely packed. It looks for the dense region of the points. If a point has enough neighbors nearby, it gets grouped with them. These dense regions become then a cluster. It also marks the point that lie alone in the low density region as outlier. It means if a point is too isolated, not enough neighbors around it, then DBSCAN algorithm will say it's not part of the any cluster and label it as a noise or the anomalies or the outlier. And in real world analogy, for example, you can imagine a crowd in a park, a group of people walking closely, it is a cluster. A person sitting far away alone, it is a noise or the outlier. And if we talk about advantage, it is generally used to find the arbitrary shaped clusters. It automatically identifies outlier also. And similarly, next advantage can be no need to specify the number of the clusters in advance, whereas in K-means algorithm we have to specify the number of the clusters in advance. And the disadvantage, choosing a good this EPS value and minimum point is not always easy. So this can be a disadvantage of these DBSCAN algorithms. And also it does not perform well when cluster have varying density. And the next disadvantage can be it is sensitive to scale of features. So pre-processing, example normalization of the data set is extremely important. And in next slide, this is the some of the comparisons between the DBSCAN and the K-means algorithms. For example, DBSCAN is a density-based algorithm, whereas the K-means is a centroid-based algorithm. And next is the DBSCAN find the number of the cluster as well as the noise, whereas the K-means algorithm finds only the k number of the cluster and it does not consider the noise present in our data sets. Due to this, DBSCAN is critically important for the task where we need to find the noise or the outliers or the abnormal patterns. Next is DBSCAN handles the noise, that is outliers, whereas the K-means does not handle the noise, it simply generates the clusters. But in case of the DBSCAN, it will generate the cluster also, it will identify the noise or the outlier also. And here clusters required, no need to specify in case of the DBSCAN, but in case of the K-means we have to specify in advance the value of the K, that is the number of the cluster that is required. So in use case summary, for example, when to use this DBSCAN or when to use this K-means scan algorithms. We can use the DBSCAN algorithms. For example, if we don't know the number of the clusters in advance, then we can use this DBSCAN algorithms. Also similarly, we can also use the DBSCAN. For example, if we want to detect the outliers, in that scenario also we can use these DBSCAN algorithms. And next, for example, if the data has some noise or irregular shapes, then in that case we can use the DBSCAN algorithm in place of K-means algorithm. Whereas the K-means algorithms can be used if the data is clean and cluster are in spherical forms. And we can also use K-means when we need the faster performance on the large data sets. At that time we can consider these K-means algorithms. Now let's go to the coding part, how to implement this DBSCAN algorithms. Here is the coding for these DBSCAN algorithms. Here we are not creating the DBSCAN algorithms from the scratch, but in place of that we are just inputting this DBSCAN algorithms that is present in the sklearn library. So this is the here in this line of the code we are importing the library. We are importing this DBSCAN algorithm from the sklearn.co clusters. Next, after that, in order to generate our data sets, we are using again we are importing it from the sklearn.datasets, and to make a data set we are using the two functions make moons and make bob. Generally, make moons is, function is used when we are trying to generate a cluster in the form of the moon shape, and if we want to generate the cluster in the forms of the spherical shape, then we will use this make block function. And here in this code we are importing the matplot library.pyplot as PLT for the visualization of our datasets. Now let's run this code. Now this code has been executed. Now here in this code we are using the function make moons. We are importing this function from the sklearn in order to create a moon shaped clusters, and for this we are importing the 300 samples. It means 300 points will be randomly selected, and here in this code we are adding noise value 0.05 in order to map with the real world scenario, because in the real world scenario the data set might contain the noise. Therefore we are adding the value of the noise 0.05. Next is the X. This is the data set that has been extracted using the make moon function, and this X data set, this is the name of our data sets, and it contains the 300 samples, that is the 300 points. Whereas this blank means we since this DBSCAN is unsupervised machine learning algorithms, so label are not considered, so we are not letting this value, we are not extracting this value, we are only extracting the value of the X, that is the data sets. Now if we check the value of this X, it will say there are 300 samples are there of 2 dimension. This is the first 300 samples of dimension 2. It means there are X as well as Y coordinates will be there of points. If I will try to print the value of the first element of this data sets, it will print this one. This is the first element, this is the X coordinate, and this is the Y coordinates. And if we try to see the samples of this X data sets, I will simply run these codes, and it will see, you can see here there are total 300 samples are there, randomly generated samples from the function make moon. These are the X coordinate, and these are the Y coordinates of the points. Next, here in this line of the code we are trying to implement the DBSCAN algorithms that we have imported from the sklearn library. We are using the DBSCAN. We have imported this DBSCAN from this sklearn library. Now here we are specifying the value of the EPS, that is the 0.2. It means the radius of the generated cluster will be 0.2. It means if 5 points will fall inside this radius, then only the cluster will be generated, else the cluster will not generated, because we have specified here the value of the minimum points, that is the minimum sample is 5. So in order to form the cluster there should be minimum 5 points. It means to form a core points there should be 5 points within the radius 0.2, then only a cluster will be formed, else the cluster will not be formed. So minimum group size to form a cluster is 5 nearby points, including the starting point itself, and if it has less than 5 points in its EPS neighborhood, that is 0.2, then it is truly isolated and will be labeled as -1 by our DBSCAN algorithm. Here -1 means label -1 means it is an outlier, it does not belong to any cluster. Next is EPS value. Generally, what it is? It is the radius of the neighborhood around a point. It means within this radius, if the point falls, then they are the core points, and they forms a neighborhood. Think of it like a circle around these data points. What will be the impact if we increase the value of this EPS, or if we decrease the value of this EPS value? What will happen? If let us consider, if the value of this EPS is too small, then many points won't have enough neighborhood, and they will be labeled as noise. Means very few or no cluster will be formed. And if we set this some optimal value like 0.2, then it will capture the dense area well, and good clustering will be formed with the minimal noise. And if we make the value of EPS very large, then many unrelated points will fall into the same neighborhood, and cluster will merge. Less meaningful groups will be created. And next is this minimum samples. I have already told you this. Actually, it is the maximum number of points in a neighborhood within the EPS to be considered a core points. If these points fall within the EPS radius, then they will be considered as core points, as else they will not be considered as core points. And what will be the impact if we increase the value of this minimum sample or decrease the value of this minimum sample? If let us consider, if the value of this minimum sample, that is that will be equal to 2 or less than 5, then it means if we reduce the value of this minimum sample, then many points become the core points, including the noisy one will also, and it will create many small cluster, or also it can merge the noises, so it is not good. And if we set some optimal value like 5, 6, then cluster goes properly only from the dense areas. It means giving some meaningful results. And if its value is too high, for example 8, 9, 10, 10 plus or 11 plus, then fewer core points will be generated, and it will be harder to form a cluster, and more points marked as noise. Next is let's run this code first. It's executed. Now here we have imported this DBSCAN algorithms, and this DB is the name of our model, and I have mentioned it DB. You can mention any name, you can give any name to it. Now I am going to fit this DB model with my dataset X, and for this I am using fit functions. I will execute this line of the code. Now it has executed. This code has been executed, and here I am was extracting the value in the labels. It means if two cluster will be generated, then 0 represents the first cluster and 1 represents the another cluster. And if the noise is present, then the value of these data points inside the label will be -1. First, let's run this code. Labels, I have already executed this code previously. You can see here there are altogether 300 labels are there. It means which point belong to which cluster, either it contains some outlier or not. If I try to print this value, you can see here this label contains this label. First, this code has been executed properly or not. Let's execute it from the beginning. Yeah, this code is executed, this code is executed, this code is executed, this code is executed, this code is executed. Now yes, this code has been executed. Labels, you can see here the value of the label is altogether there are 300 points are there, because in our data set we have 300 data points that we have selected randomly. So here 0 means these points belong to the first cluster, and 1 means these data points belong to the second cluster. And if here there is some minus value is there, then it means it does not belong to the any cluster. It is a outlier, it is a noise. Here -1 represents that data point is a outlier or noise. Generally, when we run the db.fit function, it just run once and assign the label based on the local density, not by optimizing over multiple epochs. Whereas in case of the k-means algorithms, we train our models for different number of iteration. But in case of this DBSCAN, we does not iterate over dataset repeatedly, but we just runs it once and assign the label based on the local density, and not by optimizing over the multiple epochs. And you can say that here in this DBSCAN algorithms, no epochs or iteration occurs. It's a non-iterative algorithm. All clustering is done in a single pass using parameters like EPS and minimum samples. Next here for the visualization, I have done this code. I have imported the matplot library, import matplot library.pyplot as PLT, and then from PLT I'm visualizing my datasets. Here the X, this will represent the X coordinate of my datasets, and this represent the Y coordinates. And here C represents equal to labels. It means it will color each point by its color label, and C map I am specifying for this. It is a nice color map for distinct color. Next is plt.title and plt.show. It adds a title and shows the plot to set the title as DBSCAN clustering. And if I execute this code, it will create the cluster from my data points. You can see here in the form of the moon, it is generating a cluster. Outlier will be some here. If this is the dataset does not contains any outliers, so here you can see there is no negative value is there in this datasets. It means no noise is present inside these datasets according to these settings that I have chosen. If there would have been some outlier, for example, if some points would be here or here or here, then that point will have some -1 labels, and it will be considered as outlier. And here this is the complete code for this DBSCAN that I have already shown you. This is the complete code, and here I am using a make moon function for generation of the clustering, and you can also use the make blob function. The make blob function will create some spherical shape cluster shape. Here from make moons I am generating this moon shaped cluster for my data points, and if you want to generate some spherical shape cluster, you can use this make blob function. This is the same code I am specifying here, center as value 3, but this make blob function does not require the value of the noise to be inserted, so it does not accept that parameter. So I am removing that noise parameter 0.05. I am eradicating it from here, and all the rest of the codes are same. And you can see here when I run these codes, it has generated the spherical clusters, and these points that does not fall within the cluster are outliers, and if you check their labels, there will be some negative values there. If I print these labels, you can see here this is the first cluster, this is the second cluster, this is the third cluster, and this here, so I think some minus value is there. This minus value means these points are the outliers. This is the outliers in this data sets, in these visualizations. So this is how you can use the DBSCAN algorithms to generate a cluster, and for this you can use the dataset generation function like make blobs or make moons. You can import the dataset from the sklearn library, sklearn.cluster, import make moons, make blobs, and make moons will generate the moon shaped cluster, whereas the make blobs will generate some spherical cluster. And most important parameter in the DBSCAN is this one, EPS, and the minimum number of the sample. It has to be specified in the advance, whereas where this EPS represents the radius of your cluster, and this minimum sample represents the number of the points required to form a cluster. So for today only this much. See you on the next session.